We all love magic and we love miracles, don't we? Albert Einstein said, there are only two ways to live your life. One, as though nothing is a miracle, and the other is as though everything is a miracle. Today we will explore the chemistry behind magic tree with an attitude of a miracle. The video is in three parts. Magic tree part 1 is about a chemical solution which we call magic water that is used in growing the magic tree. Do you know that the information available about these chemical crystal trees are either incomplete or misleading? It is hidden because it's a business secret. Magic tree was one of my products, so it was my business secret too. I am disclosing it today in the spirit of innovation. Magic tree looks like a simple product. The box contains only three things: magic water, cardboard paper tree cutting, a tiny dish tray. In part 1, we will learn about magic water. The magic water is a colorless liquid that exactly resembles water. You only need 2 teaspoons of this liquid to grow a fully bloomed magic tree. What composes magic water? It is simple high school chemistry and some patience. The magic water is a solution of potassium dihydrogen phosphate or KDP. It is potassium dihydrogen phosphate that has a formula KH2PO4. Make a saturated solution by mixing the inorganic salt KDP in distilled water. This is a magic water that gives you the superior quality magic tree that has smooth, tiny, needle-like crystals with colorful branches. To make a magic tree, use the paper cuttings and make it firmly stand in a given plastic dish tray. Then pour the magic water in the tray as if you are watering your plant. The moment you pour the solution, it will start to rise through the paper tray. It will rise due to the capillary action. In a short time, you will start seeing the crystals on your paper tray. The solution rises up to a height of 8 centimeters. This is how the growth looks like after 1 hour, 4 hours, and after 6 hours. The maximum height of the tree will be 8 centimeters due to limitations of capillary action. You can grow trees of many different shapes. The fineness of the needle-like crystal formation is due to KDP. No other chemical can give you this fine quality. During Christmas time, you can make magic Christmas trees in green color or multiple colors of your choice. You can make any tree shape of your imagination and choose any colors of your liking. Or you can make a snowman, a bird, a peacock, anything that is feathery, or a garden that has a snowy hill. Isn't it fascinating? What's more, KDP is an inexpensive chemical. It is non-toxic. In fact, being a phosphate, it is an excellent manure for real plants. But wait, chemistry is always a hobby of patience. While handling chemicals, always remember safety first. Make a habit of being responsible and always wash your hands after handling any chemical. Part 1 of Magic Tree ends here. I hope you have understood magic water and are excited to make it. Do you think you can now make your own magic trees or magic gardens? Yes. One of the questions should be, can we use any cardboard paper? And the simple answer is no. To know more about how to choose paper and how to color it for growing magic tree, watch next part 2 of magic tree. And here is part 2. How to prepare your magic trees, a paper for your magic trees. It took me much longer to get the right paper that worked for magic tree. Magic tree paper is about 0.15 millimeter thickness, sufficiently stiff, resistant to tearing, has cellulose in it. It could be a recycled paper or a handmade paper. You must choose dark green or brown paper so that the tree looks natural. Here comes an important part. I tested hundreds of papers to grow a magic tree and I was disappointed. The crystal growing were poor and my tree looked very scanty or inadequately grown. I then chemically treated the paper by soaking it in a diluted solution of KDP for a few hours. The treatment of the paper enhanced its capillary action. How do you color your magic trees? Use good quality food colors and just color the edges. Thoroughly dry the paper after treatment and after adding colors. Why do you think we need to treat the paper? The answer to many such questions, the scientific analysis, the reasons, processes, refinements, catalysts, and strategies are explained in part 3. Part 3 talks about how to convert a simple idea into a product. I used deductive logic in the journey of an idea to the product magic tree. How do you assess an idea? Do you really need an apple to fall on your head? A simple idea like magic tree has its simple story. I had bought 5 magic trees at an exhibition in 1998. I was fascinated by the idea of magic trees, so I opened two packages and grew 2 magic trees. I felt curious about the composition of magic water. All I wanted to know was what was the composition of magic water, which looked exactly like water, magic water. After I used 2 packets, I was just left with 3 sachets of magic water, and that was just 30 milliliters, very small quantity. It wasn't a product of my country and I couldn't buy more. Challenged with my forgotten chemistry, I set out to investigate the composition of the chemical salt which was used to make magic water. I had to plan thoroughly. I could not take a chance to run out of the sample. As I said, I used deductive logic. My first quick observations were the magic water was colorless, so I ruled out the presence of ions like chromium, cobalt, copper, iron, manganese, and mercury. Next, the precipitation was also ruled out. It did not have an odor. It was non-toxic as it was available off the counter. It was reasonably inexpensive, so expensive salts were ruled out. My first shortlist was ready. On the cation sides, the possibility of presence of lithium, sodium, ammonium, potassium, magnesium or calcium was there. On the anion side, it could be fluoride, chloride, nitride, bromide, nitrate, phosphate or sulfate. I made a list of chemicals needed for analysis, spoke with friends with a chemistry background. The requirements were less. I needed 15 chemicals for testing and analysis, just a few drops of each chemical. I visited the chemistry labs of several colleges. Few lab technicians were kind-hearted. They allowed me to do a few tests in their labs. Few others helped me with small quantities of chemicals. I used 1 or 2 drops of magic water sample for each test. Sometimes I had to use magnifying glass to observe the reactions. I kept meticulous records. Used the solution very thoughtfully. I finally shortlisted the only possibility of potassium as cation and PO4 or phosphate as anion. There were 3 possible salts and that could make magic water: K3PO4, KH2PO4 and K2HPO4 or their combination. At this stage, I purchased all the three salts. Voila! KH2PO4 or KDP solution was the magic water. I had succeeded in finding the composition. Now, next was finding a suitable paper for the magic tree. After making a mess of paper cuttings on the floor every single day by testing hundreds of papers, I had a moment of sudden realization. The paper needed nucleation sites for the crystals to grow. Nucleation sites means tiny crystals should be distributed throughout the paper to start the crystal growth. This is the very basic principle of crystal growth. For good results, mix 1 part of the saturated solution of KDP in 100 parts of distilled water 1:100 ratio. Soak the paper overnight. Dry the paper well before the next step. The paper now is a chemically treated paper. The capillary action was significantly enhanced. Cut the paper in the shape of a tree of your choice. Keep the branches well apart to give space for the crystals to grow. Now color the edges of the paper tree with food colors. A catalyst can be added to the solution as a refinement. Add a pinch of common alum or potash alum to the KDP solution. It promotes the growth of the magic tree. To make a product from an idea, you need a large scale planning. At first glance, the magic tree appears to be a child's play. It is not. To recognize your idea as a good idea, do you always have to find solution to a problem? Think about it. A reminder here again. Chemistry is a hobby of patience. A small contamination is enough to spoil an experiment. Perseverance is a quality. If you have understood the importance of perseverance, I have succeeded in conveying my intention through this video. The experiments are from my personal diary. Thanks for watching till the end. This is Dr. Sujata, former scientist with Indian Space Research Organization ISRO. If you like the video, you can subscribe and comment in the comment box. My channel always brings beauty in expressing art through science and mathematics. I have included important links in the description box. Thanks again for watching and subscribing.